Hey guys, today's notes are going to be pretty short because we are dealing with proofs and constructions today, but we're only going to do the proof side of things. We'll do constructions when we're together in class. If you want to check out the constructions ahead of time, you can go to my website, go to the constructions page, and find constructing parallel lines. But we'll do that next time I see you in class. So the only one we're looking at then together for today is our proof. And it's been a while since we've done one of these, so let's kind of break apart the pieces here. So it says given G is parallel to H, and we see that marked in our picture. And it also says that angle 2 is congruent to angle 1. So I'm going to go ahead and mark that in my picture. I'm going to put arcs there to show that. Okay, so looking at our proof, we always want to try to do as much as we can to fill in the pieces that we know. So I know G is parallel to H is one of my givens, so I can put that right at the top there. But I also see that I have another given. Angle 2 is congruent to angle 1, and if I look through the proof, I see that in line 3. So I'm going to go ahead and fill that in. So then we only have 3 blanks to deal with. That makes life a little easier. So you're going to think back to the postulates that we have used the past few days and the theorems that we've used the past few days to help us fill in this proof. So angle 1 is congruent to angle 3 is our reason for line 2, or is our statement for line 2. We need to come up with our reason for line 2. So we know that G is parallel to H. So it might help if you turn your paper sideways if you would prefer to see those the G and H lines as horizontal lines. But we notice that angle 1 and angle 3 are on the same side of the transversal of line P, and they're in the same location. So that would be corresponding angles. Now we need to decide whether it's corresponding angles postulate or corresponding angles converse postulate. And so since parallel comes first, since we know they're parallel, we're proving they're congruent, it's just the plain postulate. If it were flipped, it would be the converse. So then angle 2 is congruent to angle 1. That's a given statement. Now we need to determine why we can say that angle 2 is congruent to angle 3. So this time I'm not going to look at the picture for the moment, but I'm looking at my proof, and I see in these two statements, I see two statements coming together to form one statement. If you notice, these angle 1s are on the diagonal, and we're canceling them out. And we end up with angle 2 and angle 3 being congruent to each other. So when we're canceling on that diagonal, we remember that that is the transitive property of, and I need to look, and I see that I'm using congruent symbols, so that's property of congruence. So now if we know that we have angle 2 is congruent to angle 3, we then can say P is parallel to R, and we need to determine why that's true. Well, again, it looks like those are in the same location, so they're corresponding angles. They're on the same side of the transversal, so they're corresponding angles. But in this case, the angles are congruent leads to the lines being parallel. So that would be the converse statement this time. So corresponding angles, converse postulate. Okay, so those constructions are going to be saved for class time, so that's all I have for you for this set of notes. As always, come see me if you have any questions.